Here's example 5 with integration by substitution. So this one's going to be a little trickier because there is something we have to do first before we can do the substitution. So remember, when you do a substitution, you're looking for a function and its derivative, or maybe a constant multiple of its derivative. So what do we have? We have the integral indefinite of x squared over 1 plus x to the 6th dx. Okay. So you know, if we try and let u be 1 plus x to the 6th, then du is 6x to the 5th dx, right? And that's not really going to work out because we have an x squared, not an x to the 5th. And you know, we can try and mess around with it a little bit, but it's just going to be very complicated. And it's probably not really going to work out in our favor. So we don't want to try that. But what else could we try? Well, you know, we could try to let u be x squared, but then du is going to be 2x dx, and that's really not going to help us at all in the bottom. So let's rewrite this integral. Let's do this. So this is a common trick for ones like this. You know, if the function's derivative don't jump out at you for ones like this. Remember, the other thing we said to do was try the inside guy. There's really no inside guy here. We just have one function on top of another. There's no like functions inside of functions, nothing like that. So there's no inside guy to look for, like we talked about in the last few videos. But what we could do is, so a common trick with ones like this is to say this. Okay, so x squared on top, so I'll have the dx over here. Now x to the 6th, that's the same thing as x cubed squared. Okay. Now, first of all, we do have an inside guy, right? X to the 3rd power sitting inside of a squared here. So we do have an inside guy. And also what's nice is we have a function and a constant multiple of its derivative. So now we're going to let u be x cubed. Okay, and then du is now 3x squared dx. Okay. So let u be this function here, then we have a constant multiple of its derivative. So here's x squared dx, right? So let's go ahead and rewrite this now. This is going to be integral of x squared dx, and then on the bottom we have 1 plus x to the 3rd squared. Okay, so we'll zoom in on all that. So this is x to the 3rd and then squared, so just like we have over here. So now du is 3x squared dx. We don't have 3x squared dx, we have x squared dx. So let me toss in a 3. Okay, and if I do that, I have to multiply by a 3rd to make that okay. Okay, so now, now what happens? Well, that's great because now 3x squared dx, that is du. Okay, that is du. And then what about this here? Well, if u is x cubed, then this is just 1 plus u squared, right? So then what does the integral become? Now the integral becomes, let's keep it over here. So the integral of 1/3 times just du on top and then 1 plus u squared on the bottom, right? So now 1/3, that's a constant multiple being multiplied by everything, so we can just pull out the 1/3. So let's zoom out now. So this is going to be 1/3 times the integral of, now let's also rewrite this like this, 1 over 1 plus u squared du. So this is much better, right, than this. I mean, this isn't really too complicated. Just x squared over 1 plus x to the 6th, but when you look at it, you know, nothing really jumps out as obvious, you know, unless if you've been working with these for a long time, then you'll know to do this kind of thing right away. But if you don't know that, this is another common trick. So, you know, look for a function and a constant multiple of its derivative. If you don't see that, look for the inside guy. If you don't see that, and if it's something like this, you know, maybe try something like this. So what, to reduce it to a form like this, and what is this? That's the arctangent, right? So when you integrate this, you're going to get the arctangent. So this is a 1/3 times arctan of u, and then plus c, right? Because it's indefinite, so we have to say plus c. So remember, we're just integrating 1 over 1 plus u squared du, and when we integrate that, we just get arctangent of u. So we're not done yet, right? We have to go back to x. Our original problem was in terms of x, so we have to express our answer in terms of x, because it's indefinite. So this is a 1/3 arctan of x cubed, and then plus c. Okay, so that's the answer there. So, you know, this one wasn't really too bad. You know, the math behind it wasn't terrible, but it's just the hardest part of this one, I'd say, is just knowing what substitution to make. And sometimes that can be kind of tricky, especially with ones like this. You know, it's not really obvious. You know, it doesn't jump out at you right away, but this is just another thing to try. Okay, let me try rewriting this thing on the bottom here as something squared. Okay, so if I have, you know, 1 plus something squared, then maybe I could use a substitution to reduce it so that I can use this arctangent formula, okay, to reduce or transform it. So x squared over 1 plus x to the 6th, well, I can rewrite x to the 6th as x cubed squared. Then I can do a substitution to transform that, into something involving the arctangent. Okay, so we took this kind of complicated thing, not too bad, but just don't know how to work with it directly, and we transformed it using rewrites, and then, so we used a rewrites and then a substitution. Okay, so we rewrote x to the 6th as x cubed squared, then we used the substitution to transform that into a simple arctangent thing here. And then integrates, have a plus c because it's indefinite, and then go back to your original variable x, and then that's our final answer here, 1/3 arctangent of x cubed plus c. And that's example 5 with integration by substitution.